Hello friends, today we'll start with analysis of cables supports at different levels wherein the two top supports of the cable are at different levels. Note down the problem. A rope is hanging from 2 points, that is a suspension cable rope A and B 30 meters apart horizontally. So the horizontal distance between the cables between the 2 points is 30 meters. Point B is 3 meters lower than A. So let me draw those points. Let this be point A. This will be the horizontal line. Point B is somewhere here in this line and it is 3 meters below this. So below this 3 meter, let me identify as this point. So this is my one point, this is my second point. It supports a UDL of 10 kilonewtons per meter over entire horizontal span or length. Determine the position of lowest point if the rope has a sag of 3 meters below point B. It means the lowest point of the rope or the cable is 3 meters below point B. Let this be point A. This is point B. The sag or the lowest point of the cable is 3 meters below this, vertically 3 meters below this. Let that point be somewhere here. So I will draw a rope joining these points. So this is my cable. Let this be point C. So let me draw the forces. H, VB, VA, H. The horizontal distance is 30 meters. Distance between 2 points A and B, that is 3 meters. Point C is 3 meters below this. So let me draw a horizontal reference line for the lowest point. This distance is 3 meters. Now overall this distance from here till here, 3 plus 3, 6. Let this point from here so here UDL is supported. (10 kilonewtons per meter). From this lowest point, let these distances be L1, L2. Always remember, if this is my point 1, vertical distance of point 1 or point A from B, from the lowest point C, it is always measured as D1. So D1 is measured from A to the lowest point. Similarly, D2 is measured from point B or point 2 to the lowest point. So let this be D2. Corresponding to D2 is L2. Corresponding to D1 is L1. So I have a relation between D1 and D2. So these are the forces. Now let us start. Step 1. Horizontal distances. Horizontal distance means first I have to identify L1 and L2. I have the relationship L1 plus L2 is equal to L is equal to 30 meters. Let that be equation 1. L1 plus L2 is equal to overall 30 meters. So I have the equation L1 by L2 is equal to under root H1 by H2. So I know H1 by H2 or D1 by D2. Dip D1 by D2, same thing. So I know the dip distance is D1 and D2. D1 is 6, D2 is 3. So that gives me root of 2. Therefore, L1 by L2 is equal to root 2 is 1.4142 or L1 is equal to 1.414 L2. So substitute these values in equation 1. Substituting L1 is equal to 1.41 L2 in equation 1, we get L2 is equal to 12.43 meters and L1 is equal to 17.57 meters. These are the horizontal distances. Now I need to find the length of the cable, the inclined length of the cable. For supports at different level, inclined length of cable is equal to S is equal to L plus 2 by 3 d1 square by L1 plus d2 square by L2. This is the equation. So substitute all the values. S is equal to L, horizontal distance is 30 plus 2 by 3 outside the bracket d1 is 6 square by L1 is 17.57 plus d2 3 meters 3 square by 12.43 L2. So solving this I get S is equal to 31.85 meters. Now let us start this third step, finding the reactions. First equation I can write summation of vertical forces V is equal to 0. So upward forces are positive, so upward forces are VA plus VB minus load into span. Load is 10 kilonewtons per meter, span is 30 is equal to 0. Or similarly I can write VA plus VB is equal to 300. Let this be equation 2. Now let us start writing about hinge points. Summation of moments about MA is equal to 0. Clockwise forces are positive. Keep your finger at A, start analyzing the beam. So when I start analyzing from A, I can write VB into perpendicular distance 30. So VB is negative because anti-clockwise, minus VB into 30. H produces clockwise moments, so anti-clockwise. So again that will be negative, minus H into perpendicular distance is 3, minus H into 3. Next, load is UDL. It produces clockwise moments. So 10 into load into span. 10 load is 10, span is 30, CG distance half of it, 30 by 2 is equal to 0. So I can write the equation summation of moments about A is equal to 0, clockwise moments are positive, minus VB into 30 minus H into 3 plus 10 into 30 into 30 by 2 is equal to 0. Solving this I get the equation 30 VB plus 3H is equal to 4500. Let this be equation 3. So similarly I can write summation of moments about C is equal to 0. Moments about hinge point C. Again clockwise moments are positive. When I am writing summation of moments about C is equal to 0, let me consider RHS side. So forget this part of the cable. Consider only part of the cable between C and B. Clockwise is positive. So VB. So it will be negative moment because VB produces anti-clockwise. VB into perpendicular distance is L2. Next, H produces clockwise plus H into perpendicular distance from here to here, it is 3 meters. H into 3. Then UDL, this part of the UDL, L2 part, load into span into CG, 10 into L2 into L2 by 2. So I can write the equation minus VB into L2 plus H into 3 plus load into span into CG distance 12.43 divided by 2 is equal to 0. Or same I can write minus 12.43 VB plus 3H is equal to minus 772.5. Let this be equation 4. So equation 2 and equation 3 and 4 two equations, two unknowns. VB is unknown, H is unknown in both the equations. Solving these two, solving 3 and 4, we get VB is equal to 124.26, H is equal to 256.36. Similarly, substituting value of VB in equation 1, in this equation I get VA value. VA is equal to 175.74. So these are the reaction components. Now let me calculate maximum and minimum tension. Step 4. Maximum and minimum tension. So minimum tension is nothing but H value is equal to 256.36 kilonewtons. Already we have calculated it. Now maximum tension T max is equal to under root V square plus H square, and again V you have to consider based on highest value of VA and VB. Whichever is highest, that you need to consider. VA square plus H square. Substituting the values, I get T max is equal to 310.88 kilonewton, and it occurs near tower A. Now next step, step 5, forces in cable. Assume anchor cable is at 25 degrees to horizontal. Case 1, cable passes smooth pulley. Let me draw the diagram. On this side, on left side is my anchor cable. Let the tension be T. On right side, my cable makes an angle like this. This be theta S, theta A. Resolution of these forces. This be T is equal to under root V square plus H square is equal to 310.8. Now let me calculate this angle theta S. Theta S is equal to tan inverse VA by H. If you are calculating theta S at support B, you have to consider VB. If you are considering tower A, you have to consider VA. So substituting the values, I get theta S is equal to 34.43 degrees. First, horizontal force is equal to, so this is T cos theta S, this component is T cos theta A is equal to T cos theta S minus T cos theta A. So substituting the values, I get 310.8 cos 34.4 minus 310.8 cos 25. So substituting all the values, I get 24.23 kilonewtons. Similarly, second case, vertical force in tower. So that is given by T sin theta S plus T sin theta A. Substituting the values, I get 306.49 kilonewtons. Now second, case 2, cable passes over saddle or roller support, both means the same thing. So let me draw a diagram. Let this be saddle support over rollers. Cables are at the center of the saddle. Since the cable on both the sides are different, on this side load will be TA, on this side load will be T, that is T max, nothing but 310.8. Let this be theta S, theta A, resolution of forces. Again, theta S is equal to, I know already the equation, theta S is equal to tan inverse VA by H. I get theta S as 34.3 degrees. Now for this stability of this equilibrium equation, I can write summation H is equal to 0. So summation H means TA cos theta A is equal to T cos theta S. TA cos theta A is equal to T cos theta T, sorry, cos theta S. So substituting the values, I get TA is unknown. TA cos 25 is equal to 310.8 cos theta S. Theta S is 34.3. Substituting the values, I get TA is equal to 283.3 kilonewtons. Now second, vertical forces in tower. So vertical force is TA sin theta A plus T sin theta S. Substituting the values, I get 1871 kilonewtons. So these are the vertical forces in the tower. Thank you.